Faster than the very fabric of spacetime itself, it holds the ability to preserve its awareness of it, and as a result, it will gradually disassemble. This notion fills me with a sense of dread. At present our night sky is shifting rapidly, and within the next few decades, or perhaps even sooner, it might become utterly unrecognizable. Astrophysicists are sounding alarms, with experts such as deGrasse Tyson acknowledging the unavoidable impact of the Polaris transformation. The story behind this change is rather surprising. Polaris, known as the North Star, has long been a steady fixture in our sky, serving as an essential reference point for astronomers, navigators, and stargazers alike. However, this may soon be altered, transforming our perception of the heavens and altering how we study the cosmos. Let's take a closer look at the ramifications of this potential shift. For many years, Polaris has acted as a navigational guide for sailors and astronomers, maintaining a stable position in the sky. Its unwavering presence has been crucial for guiding travelers, but this stability may soon be challenged. In September of 2023, a paper from the esteemed Royal Astronomical Society raised questions about the future of this celestial guide. Polaris is nearing an unstable phase, one where it could potentially explode and disappear from view, forever altering the sky as we know it. Before exploring the potential consequences of this event, let's take a deeper dive into the characteristics of the star itself. Polaris stands out because of its closeness to the celestial North Pole. Situated directly above Earth's northern pole, it appears nearly stationary in the sky. It is located within the Ursa Minor constellation, also known as the Little Dipper. Polaris shines with a moderate brightness, resembling a yellow-white supergiant star far larger and brighter than our own Sun. However, Polaris isn't a single entity. It's part of a complicated triple star system comprising Polaris A and Polaris B as a binary pair, while a third star orbits the two. The gravitational forces produced by these stars influence their orbits and behavior, and disturbances in these interactions could cause fluctuations in the star's brightness or pulsation patterns. However, the exact nature of these forces is still not fully understood. Polaris is situated approximately 323 light-years from Earth, meaning that the light we currently see from it began its journey quite some time ago. Therefore, if Polaris were to explode, we wouldn't notice it for over 300 years. In fact, it's even possible that Polaris has already exploded, and we have yet to see the light from that event. Throughout history, the North Star has held immense cultural, navigational, and symbolic importance. Its constant position has made it an indispensable guide for ancient sailors navigating the seas and lands. Symbolically, Polaris has come to represent steadfastness and direction, remaining unchanging in the ever-shifting sky. For astronomers, Polaris has been a vital reference point in the study of stellar movements and variable stars. As a Cepheid variable star, its periodic changes in brightness have offered key insights into stellar properties and the nature of variable stars. This characteristic has also played a critical role in determining cosmic distances and calibrating scientific instruments. These pulsations follow a predictable rhythm, making the star's behavior easier to forecast. However, recently Polaris has shown signs of deviating from this expected behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting further investigation into this strange anomaly. Rather than following its usual pattern, Polaris has begun to exhibit erratic dimming, raising concerns that the star may be nearing the end of its life cycle. This is consistent with patterns seen in stars approaching their final stages. The gradual lengthening of Polaris's pulsation period, which was once stable, can be traced to interactions within its star system. There has been a yearly increase of approximately 4.5 seconds in the pulsation period, and while this may seem minor, it carries significant implications. Some astronomers propose that gravitational interactions between the stars of the Polaris system could be driving these changes in its atmospheric conditions, directly impacting its pulsation patterns. Others are more concerned that Polaris is approaching a critical stage that could result in an explosion. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have demonstrated complex brightness variations, leading to worries that they may be on the verge of a dramatic explosion. Stars in their final stages often show such anomalies before reaching the end of their life cycle. NASA has shown greater concern about Betelgeuse, but formal attention has not yet been fully directed toward Polaris. As a Cepheid variable star nears the end of its life cycle, it goes through several phases, including the red giant stage and ultimately a supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict it has entered the phase of helium exhaustion, which is a typical stage for giant stars nearing their end. These irregularities in Polaris's behavior align with patterns observed in stars at the twilight of their life cycle. However, solid evidence of an impending supernova is still uncertain. Astronomers continue to track these anomalies to better understand the fate of Polaris. Should Polaris undergo a supernova explosion, it would likely be a monumental event in the sky, potentially outshining the Moon and remaining visible for days, weeks, or even months. Its brilliance could drastically change our view of key constellations like the Big Dipper or Ursa Major, in which Polaris plays a crucial role. Fortunately, Earth would likely remain safe regardless of whether Polaris explodes. Given its size and distance from us, while a Polaris explosion might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would certainly take note of this, generating widespread interest both in the academic world and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a supernova closer to our planet. But what will happen to Polaris itself? What will its fate be after a potential supernova explosion? We must first clarify that while large stars typically end their lives in a supernova explosion, this is not likely to happen with Polaris. When a massive star undergoes a supernova, it experiences a cataclysmic explosion, marking the final phase in its life. This process involves the complete collapse of the star's core, creating a violent shockwave that causes the star to burst apart. However, Polaris is not massive enough to undergo such a violent explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This transition will not trigger a supernova, but will instead result in a quieter end as Polaris evolves into a small, incredibly dense stellar remnant. A white dwarf is the compact core of a low to medium mass star that has used up its nuclear fuel. This remnant, although only about the size of Earth, will still be as massive as the Sun. Once this process occurs, we will no longer observe Polaris as we see it today. The mysterious behavior of Polaris highlights the necessity for deeper studies and focused research. Astronomers must address the complexities surrounding its irregular pulsations and offer meaningful responses to determine the star's future. The potential loss of Polaris as a celestial reference point raises fundamental questions for astronomical research. Ground-based telescopes and measurements of celestial distances would need to be recalibrated, affecting the accuracy of cosmic assessments. The disappearance of Polaris would also disrupt navigation systems and cultural practices that rely on celestial markers, underscoring the significance of this event. Understanding the forces causing these irregularities is key to advancing our knowledge of stellar evolution. The investigation into the factors behind Polaris's erratic pulsations requires cooperation across multiple scientific disciplines and the development of advanced models and observational techniques. The implications for navigation and astronomy. Polaris has served as a guiding light for centuries, used by travelers to find true north. If the star dims, shifts, or disappears entirely, modern navigation would not be severely affected thanks to GPS and advanced technology. However, for those who rely on celestial navigation, such as sailors and aviators practicing traditional techniques, this would present a challenge. Future generations learning astronomy or navigation would have to adapt to a sky that no longer features Polaris in its current role. From an astronomical standpoint, losing Polaris as a reference point would require recalibration of many observational tools and methodologies. Since Polaris has played a role in measuring Earth's axial precession, the slow wobble of Earth's rotational axis, its absence could slightly alter how scientists study planetary motion over long periods. A shift in the night sky. The disappearance or drastic dimming of Polaris would not only impact our navigation, but also change the familiar look of our night sky. Constellations anchored by the North Star could appear less recognizable, subtly reshaping how we perceive the cosmos. This shift would be similar to how ancient civilizations viewed the night sky differently from how we see it today due to natural changes in star positions over millennia. If Polaris were to undergo a transition into a white dwarf, its brightness would eventually fade, leaving us without the shining beacon we have long relied upon. However, Polaris's location in the sky would still mark the approximate position of true north, even if the star itself became too dim to see with the naked eye. Could a new North Star replace Polaris? Interestingly, Polaris is not the only star to have held the title of the North Star. Due to Earth's axial precession, the designation of the North Star changes over thousands of years. In the distant past, Thuban, in the constellation Draco, served as the North Star around 2700 BCE. In about 12,000 years, Vega, one of the brightest stars in the sky, will take Polaris's place as the new North Star. While this gradual shift is expected due to the Earth's wobble, the sudden loss or dimming of Polaris would still be an unexpected event in human timescales. Scientists continue to monitor Polaris to determine whether its fluctuations are leading toward an inevitable fading or whether it will stabilize once more. What's next for Polaris? For now, Polaris continues to intrigue scientists. The mystery of its erratic pulsations, potential helium depletion, and long-term stability remains an open question in astrophysics. Advanced telescopes such as the James Webb Space Telescope and other space-based observatories may provide further insights into the star's future. If Polaris is indeed nearing the end of its stable phase, we may be witnessing a slow but inevitable transformation. Whether it fades into a white dwarf or experiences a more dramatic change, its journey will continue to be a subject of fascination and study for years to come. As humanity looks toward the stars, Polaris remains a reminder of the ever-changing universe. Its fate, much like that of all celestial bodies, serves as a testament to the dynamic and evolving nature of the cosmos. Whether we continue to use it as a guiding light or witness its transformation into something entirely different, one thing is certain: Polaris will always have a place in our history, our science, and our wonder for the universe.